All right, today we're going to talk about the Q factor in an equalization. So here in my parametric equalizer, we have our target frequency, we have our gain, and then down here we have our Q, or width. Um, Notice that they all have a 2 value in there right now. So let's just bring this, well, let's undo that. Nope, I can't. Okay. Let's say this is 800 hertz and we want it to go up 12 decibels. Okay, right now the Q is set at 2, so that means that it's just referring to how wide this thing is. If the lower the number, the wider it's going to be. So if I put a 1 here, see how much wider the effect is. If I put 0.5, then it's even wider. I could go steeper, go like 12 or 24, something like that, and now it only affects that frequency and not as much to the sides of it. So when we're dealing with these kind of filters, you need to know how to figure out this Q and what it means. So let's say I wanted something at 1 kilohertz, 1000 hertz. And let's say I wanted it to affect everything 1 octave below it and 1 octave above it. So 1 octave below is 500 hertz, so right about here. 1 octave above is 2 kilohertz, so right there. So I just happen to know this, but the Q for that would be 0.7. So now if I drag this down, whatever value I have there, it's also affecting. So if I have -8, then it should be half that at the 500. So yeah, it's about -5 right, or -4 right there, -4 right here, and then twice that, and it'll be at 0. Okay. So let's go over to this program and let's. There's our little filter drawings. Okay. So here's the calculation for Q. So Q equals your target frequency divided by the bandwidth. So how you calculate bandwidth is you take the high frequency. Bandwidth equals high frequency minus the low frequency. Okay, so if our target is 1000 hertz and we want it to affect 1 octave above and 1 octave below, okay, so 1 octave above that is twice the amount, so that would be 2000. 1 octave below 1000 is that divided by 2, so that's 500. 2000 minus 500 is 1500. Okay, so here our target is 1000 divided by our bandwidth, which is 1500. And let's go to our calculator. 1000 divided by 1500 equals 0.66666. Okay, so it's basically 2/3. And this ratio is always going to be the case. Anytime you have a bandwidth that is 2 octaves, right? 1 octave below and 1 octave above. So let's just test this out again. Okay, so what if our target is 2 kilohertz? Okay, what would our bandwidth be if we want it to be two octaves? So 1 octave above, 1 octave below. What's an octave above this? 4,000 is an octave above. What's 1 octave below it? 2,000 divided by 2 is 1,000. 4,000 minus 1,000 is 3,000, so that means our target is 2,000 divided by 3,000, which is 2/3, which is, again, 0.66666. Okay. So in this situation, it's easy to figure out what frequency would be 1 octave above and 1 octave below. Once it gets smaller than that, it's harder to know specifically what frequencies they are, but theoretically, let's just say, my target is 2,000, and I want it to affect up to, let's say, 2,200 hertz. That'll be the high end of the filter, and what's the low end going to be? 200 hertz less than that, so 1,800 hertz. So that minus that is 400 hertz. Oops, 400. And 2,000 divided by 400 is, well, 20 divided by 4 is 5. Right? So I believe the Q would be 5. Oh, did I close my calculator? $2,000 divided by 400. Yeah, 5. So that means the Q would be 5. So let's go back over here and take a look at what these look like. So let's put this 2,000. Let's have our gain be 10. So remember, 0.66 was for 2 octaves, but Audition just rounds it up to 0.7. So with this filter turned on, well, let's hear it by itself first. And I'll turn it on here. Here it is off. Okay, so you can hear that boost in the high frequencies. It's pretty drastic. But now let's bring the Q down. Wonder if it'll do it while. Yeah. So if I set that to 5, now it's only affecting those frequencies that we specified in there. So let's try this. Let's try drawing one ourselves. You'll need to know how to do this for the homework. Let's set my ink to white. Okay. So let's say that we have a filter, a peaking filter set at 8 kilohertz. So where's 8 at? Right here. Okay, so right around here. Let's say I want it to go, I have a gain of, let's say I have a gain of 12. Okay, 12 dB. So that's just above this 10 line. So right there. And let's say I have a Q of 2 octaves. So that means the space that it affects should be 2 octaves, 2 octaves wide. So 1 octave below, 1 octave above. So what is 1 octave below 8 kilohertz? That would be 4 kilohertz right here. And what's 1 octave above? That would be 16. So somewhere around here. Okay. Now, what is my bandwidth? So 16 kilohertz minus, what was this one? 4 equals 12 kilohertz. So I have a bandwidth of 12 kilohertz right here, and a Q of 0.66 into infinity. Okay, so let's draw the filter here. Let's just delete those. So here's, let's mark 4 again and mark 16. So it would be, well, something like that, because at the low end of it, that's where the filter is affecting it halfway. Okay, so if my gain is 12, then here at the low end of it, the gain would be 6, and here at the high end, the gain would be 6. Okay, so something like that. Now, if I moved the center frequency to 6 kilohertz, remember, what was our bandwidth here? 16 minus 4 is 12. So if I moved my center frequency to 6 kilohertz, so right here, but I kept the same bandwidth, but my bandwidth is still 12. So now what would be my Q ratio? So 6 divided by 12. So in that case, it is 0.5, meaning the bandwidth is wider compared to the center point than it was before. Let's see what the difference is here. So if I've got 6,000 kilohertz and 0.5, yeah, see how much wider that is instead of 0.7? Not a huge difference, but all right, then let's say I kept the same bandwidth, but I moved it down here to 3 kilohertz. So what if my center point was at 3 kilohertz and my bandwidth was still 12 kilohertz? Well, remember, it is your target divided by your bandwidth. So 3 divided by 12. Oops, where are you, calculator? I can't figure this out in my head. 3 divided by 12. In that case, my Q would be 0.25. All right, so that's how you calculate Qs. Hopefully that is useful for you. We'll see you next time.